component used in a project will depend on what the project is and required to do. In all projects there will be a circuit which is simply somewhere for the current to flow. How it flows and how much it does will depend on the resistance of the circuit, resistance to the current flow, as we saw in the Ohm's law diagram, where a current flow depends upon a voltage, electromotive force, that pushes the current through the circuit. A resistor is used to limit the current flow through a device, such as a transistor or integrated circuit. Resistors are the most common component used in electronic construction. They are non-polarized, which means that they can be wired in a circuit either way around. They come in all shapes and sizes, and most have coloured bands on them to indicate the resistance value. It would be prudent to look up resistors in the RSGB or ARRL handbooks or similar publications to learn more about them and their coloured bands. It will be seen when looking through a component supplier's list of resistors that they are available in different tolerances, which means that resistance value may not always be exactly as indicated on the body of the component. They are available as 10%, 5%, 2%, 1%, and can even have closer tolerance. As an example, a 10k resistor sold as 5% tolerance will have a resistance value of anywhere between 10k minus 5% equals 9.5k and 10k plus 5% equals 10.5k. So its resistance value can be anywhere between 9.5k and 10.5k, which in most cases will not make any noticeable difference to a project. Another common component is the capacitor. In simple terms, a capacitor blocks a DC current to flow, but effectively allows AC alternate current to pass. Look at capacitor theory for a better explanation of how capacitors work. Capacitors, depending on their type, can be polarized, positive voltage connected to one side marked with a cross, and a negative voltage marked with a negative bar sign to the other, or they can be non-polarized, as with resistors. Polarization is mainly limited to electrolytic and tantalum capacitors, and can be easily seen with the respective markings on a component body. In some circuits it may not be obvious which way around an electrolytic or tantalum capacitor should be wired. This can be found by tracing or looking on the circuit diagram, which part of the circuit that connects to the capacitor is more positive than the other. In this diagram, where one end of a capacitor is connected to the collector of an NPN transistor and the other end to the base of another NPN transistor, the more positive point would be the collector of the transistor. So that is where the positive lead of the capacitor will be connected. In a power supply circuit, where the capacitor is connected across the positive and negative rails of a power supply, it is obvious. But in other circuits it may not be quite as obvious. Of course, if you are following a set of instructions from a kit of parts, this should be shown in the layout diagram which way the capacitor is to be connected. Most other capacitors, such as ceramic, polyester, polystyrene, etc., are not polarized or non-polarized, so it does not matter which way round they are connected. There are, as with resistors, tolerances with their capacitance values, and again, unless the circuit calls for precision components, then standard 5% or even 10% will be fine for all other projects. There is, however, a voltage rating, and this must be taken into account when placing a capacitor in a circuit. The voltage rating on the capacitor is normally its highest or maximum voltage that can be placed across it, and it is called its working voltage. Generally, a higher voltage rating capacitor is placed in the circuit to allow any voltage increases due to aging of other circuit components or surges such as spikes. Electrolytic or tantalum capacitors are placed across DC supply lines to filter away any AC content. Smaller capacitors, such as ceramic types, are also placed across a DC path to filter or decouple any RF voltages and signals. These are also used to connect between other components, such as transistors, to allow the signal to pass but block any DC content. There are many more uses for capacitors, and again, look up in technical publications for more information. It is tempting to look up technical data along with circuit designs and projects on the internet. While most of it is technically correct, it cannot always be guaranteed to be, especially from an unknown author or source. The best source of technical information is from technical books and manuals, as they have been fully checked and proofread before publication.